So now we're going to go back to graphing quadratics, and we're going to use a lot from what we learned last section in 10.2, and also some completing the square here. So let's take a look at this guy. The easiest way to graph a quadratic is if it's written in vertex form, which is like this, a times x minus 8 squared plus k. So let's do that with this guy. If I want to rewrite this in quadratic or in vertex form, we're going to use the steps of what we learned in example 1 and 2 in this section 10.3. So we take our b and we divide it by 2, and we square it. So -6, cut that in half is -3. -3 squared is 9. So that's my special number right there. All right, so we're going to add and subtract that special number. So I'm going to add that special number, and we're going to subtract that special number. Okay, so I did that in blue so you can see. Oh, look, if I just those cancel out. So it's the same problem. I'm not changing it. Now let's factor the first 3 terms, and that becomes x minus 3 squared, and then we get -4. All right, now this is nice because we know what the vertex is now. The vertex is 3, -4, and that's the most important point on a quadratic, because then we can use our cool shortcut that we learned about, the over 1 up 1a, over 2 up 4a, over 3 up 9a. So let's go ahead and graph this then, right? So we know that the vertex is 3, 1, 2, 3, 1, 2, 3, 4. And the value of a is 1. Like, this is our value of a right here, 1. So we could just do the cool shortcut here. Over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4, over 3 up 9, and over here. And there we go. So go ahead and graph our quadratic here. And that's that guy. Now, look at this example now. If I'm going to try to graph this guy, I'm probably not going to use this method. I'm not going to try to put it in vertex form. So why not? Well, I know that my b is an odd number right here, right? Which means that if I take half of 3 and if I square it, then now my magic number is 9/4. And what that means now is you have to plot the point. You have to go x on the x-axis, the horizontal shift of 9/4. We've already trying to count, over 1 up 1 is going to be really difficult there. So you could just go ahead and use the other method that I was showing you, which is the vertex method, using the vertex formula. So I'm going to use that method instead of trying to write it in vertex form here. All right, so I'm going to find the x coordinate of my vertex by doing negative b over 2a. So let's go ahead and set that up. So negative b, so there's my b over 2a. So I get 3/2. Okay. All right, so what we need to do now is we need to go ahead and erase that. This is kind of like in the way here. All right, so we're going to need to plug this into our original function. So f of 3/2. So that means we get 3/2 squared minus 3 times 3/2 plus 1. So I'm just plugging in 3/2 right here. So we'll get 9/4 minus 9/2 plus 1. Let's get a common denominator. So multiply that by 2, multiply that by 2. So we get 9 minus 18 plus 2 all over 4. 9 minus 18 is negative 9 plus 2 over 4. Which is just simply negative 7 over 4. So we have a vertex of 3/2 and negative 7 over 4. Okay. So now if you're asking like, dude, like how do you graph that? Well, 3 halves, 1.5, and then negative 7 fourths is 4. So that's going to be 1 and 3 fourths. So you could rewrite it like that, put 1.5, and then that's going to be negative 1 and 3 fourths. I should probably write this as a mixed number as well. That would probably, kind of be helpful there. So 1 and 1/2. So that may be a little more helpful when you graph it. So you can go over 1.5. So 1.5 and then down 1 and then 3 fourths. So now how do you find more points? Well, we actually can kind of still use our shortcut where you go over 1, up 1, and all that. We'll have to check and see what is our value of A. So our value of A is 1, which is nice. So since the value of A is 1, we can still kind of play around with that. So the thing is that now we're just kind of be eyeballing it though, which isn't the best way, right? So if you actually are looking for exact points, then trying to say over 1, up 1, and all that, that may not be as good, because this one, they're all nice points. They all landed on lattice points. That's what these points are called when they cross. They're called lattice points. So what I suggest then is well, we at least need 2 more points to graph a parabola, like bare minimum. It'd be nice to have 5, but if we had 2 more, that'd be great. So I know that my parabola is actually going to only open up. So how do you know that? Well, if you come up here, since A is bigger than 0, A is positive, that means that the parabola has to open up. And if it opens up, then that means that my parabola is going to hit the x-axis twice. So what we can do is this. Check this out. We can find the x-intercepts. That's what I want to try to find now. So if I go back up here, x squared minus 3x plus 1, I want to find the x-intercepts. And if it's factorable, awesome. If not, well, that sucks for us, because that means we're going to have to either solve this by completing the square or by doing the quadratic formula. Either one of those is going to work for us. So like, I'm just going to have to go down here, x squared minus 3x plus 1, and we're going to have to do some work then. So x squared minus 3x plus 1. So it looks like this is not factorable. So we're going to have to, I guess, just use the quadratic formula then. All right. Well, let's go and get this thing cracking then. Remember, our A is going to be 1, our B is going to be negative 3, and our C is going to be 1. So again, I get my A, B, C, and now we're going to go ahead and start plugging away in here. The way that I like to do this is just put blank parentheses so that I can just plug them straight in without worrying about signs and messing up on that there. Okay, so x equals negative b. So whatever b is negative 3. Plug that bad boy right there. Negative 3, 4 times a times c, ac, all over 2a. Cool beans. So let's try to simplify this guy. So negative, negative, that's going to give us a positive, so that's 3 plus or minus the square root. Negative 3 squared is going to give us 9, and then minus 4 all over 2. So we get our 2 roots, 3 plus or minus radical 5 all over 2. And those are our 2 roots. And so you could just use a calculator actually to put 3 plus radical 5 over 2, and that's going to give us our decimal, just so that you have a better accurate reading of what it should be there. So I'm just going to do that real quick here. So 3 plus radical 5 divided by 2 Yeah, so if I did the first one right here, this thing's going crazy. Let's try that again. If I did the first one right here, 3 plus radical 5 over 2, that's going to be approximately 2.62. Okay, and then if I do 3 minus radical 5 over 2, let's go and do that one then. See what we get. So we get 0.38. So one is basically like 2.5. So we'll have 2.5 right there, and the one's about 0.8 right there. So that's going to be enough points here. And so as you can see, this one took a lot more work because of its fractions and decimals. So that's just one way that you can do that, is by using the vertex method, which is the nicest, but then when they don't come out, you might have to use the formula to get that.